So we'll see another dimensionality reduction algorithm. So that is linear discriminant analysis. So basically, linear discriminant analysis is a dimensional reduction technique. It is used as a pre-processing step in machine learning, and also with respect to applications of pattern classification. The goal of LDA is to project the features in higher dimensions onto lower dimensional space in order to avoid the curse of dimensionality. So again, we have seen already what exactly is this, and also reduces the resources and dimensional cost. Okay, so the original technique was developed in 1936 actually by a person known as Ronald A. Fisher, who actually named it as just linear discriminant, or Fisher's discriminant analysis. Fisher's discriminant analysis. The original linear discriminant analysis was described for two-class techniques. The multi-class version was later on done by C.R. Rao as multi-dimensional reduction analysis. So in this video, we'll be seeing about LDA. So a linear discriminant analysis in short is known as LDA. So LDA is a supervised classification technique that considers a part of crafting competitive machine learning model. So that categorize this category of dimensional reduction is usually used like in terms of image recognition and predict analysis in the market. So quick recap of dimensional reduction. So again, it is an important application of machine learning using like data mining, bioinform, and infer. The agenda is to remove reductant or dependent features by changing the data set onto lower dimension. So we'll see exactly how it has been done with LDA. So before that, again, with respect to considering an LDA is always when a logistic regression fails in terms of classification. So basically, logistic regression is a simple and a powerful linear classification algorithm. So however, it has disadvantages that led to alternative classification algorithms like LDA. Okay, so these are the limitations of logistic regression. So the first is two-class problems. So two-class problem, logistic regression is a traditionally used two-class and binary classes problem. Like we had already seen example, final outcome would be yes, no, or something like that, a dog or a cat. So though it can be extrapolated and uses in multiplexers, like this is again rarely performed. On the other hand, the linear discriminant analysis is considered as a better choice wherever multi-class classification is required. So in this case, the binary classification, both logistic regression and LDA are applied. Okay, in the case of binary classification, else multi-class. So here LDA is linear discriminant analysis, which is dimensional reduction. So it will do the reduction and also apply the machine learning model. Okay, so training of the machine learning model. So how exactly is the practical approach of our linear discriminant analysis we'll be seeing. So let us consider a situation where we have plotted a relationship between two variables where it is represented in different color over here, so red and blue, and here is the graph with the two variables x1 and x2. So those are the two features. So if we are like willing to reduce the number of dimensions to 1, you can just project them to the x-axis like this. Okay, so you can just get it onto the x-axis and you will directly get it like in this way. Okay, so there will be this approach is actually neglects any helpful information, so you completely like kind of ignored with respect to the x2 axis, right? So that is the y2 x2 feature. So this is just directly dropping down the one of the variables or the features. Okay, so however, if you're if you want to get a LDA plot, the advantage of LDA plot, it uses information from both the features. Okay, so it basically creates a new axis in which turn this is the way how it will be creating. So basically it will be creating a new axis. Okay, so new axis where in turn it will has two basic conditions. Okay, so that should minimize the variance. Okay, the variance should not be more, and maximize the class distance. Okay, so it should have the maximum of the class distance. So now after getting this new axis, so now we'll be just putting down pushing down to the axis, on the axis, plotting on the axis. So we'll be getting something like this. Okay, so again, now even though there is a few information lost, but still we have pretty good accuracy. Like ultimately, it will be viewing like this, and also similar to how we name in PCA, like PC1, PC2, with respect to the components what you use. Here it's like LD1, LD2, linear discriminant. Okay, so this is how the practical approach of the LDA model is, and how exactly it works is like we have few more theoretical aspects. So LDA focus on primarily projecting the features into higher dimension spaces to lower dimension. So the three steps is like we need to calculate the separate separability between classes, which is the distance between the means of the different classes. Okay, so this is also called as between class variance. Okay, so what are the means between different classes? And secondly, we have to calculate the distance between the mean and the sample of each class, so it is called as within class variance. Okay, and finally the third thing what we need to do is we have to construct a lower dimensional spaces which maximizes. So this is a very important, so basically these are the rules which LDA follows. So the rule is nothing but which should the lower dimensional spaces has to maximize the between class variance. Okay, so between class variance, which we just saw, the distance between the mean of different classes, and minimize the within class variance. Okay, so that is the mean and the sample of each class. Okay, the distance between the mean and the sample of each class, so that should be minimum. So then you can consider P as the lower dimensional, and this can also be called as Fisher's criterion. So instead of P, you can give it the name as LD1 also. Okay, so even that can apply. So that is how exactly we will be checking. So again, with respect to representation of LDA, it is again pretty straightforward. The model will consist of statistical properties on the data that has to be calculated for each class. So the properties can be calculated by using over the multivariate Gaussian in the case of multivariables, and finally we'll get the multivariate like kind of means and the covariate matrices. And predictions are provided like predictions are made by providing a statistical property in the LDA equation. So again, we are not covering up the equation by using the equation. So there is some kind of equation, so that is like it will take the maximum value of the probability. Okay, so again, not going into the this one, I am not exactly able to recall it. So here again the property are estimated for the data, and finally model value into you can save up using a file or something to create an LDA model. Okay, so that is how data representation is done, and how to prepare data from LDA. So before that, I would like to give insights of how LDA model learns. Okay, so basically the assumption is like each variable in the data is shaped into the form of bell curve when plotted. Okay, so that is like the Gaussian, which we had already seen multiple times. So the value of each variable vary around its mean by the some amount on an average. That is like each attribute has the same variance. Okay, so it should have the similar variance, so that you can have the equal amount of information weightage. The LDA model is able to estimate the mean and variance from scratch for each classes with the help of these assumptions. Okay, so those are the assumptions, and the mean value of each input for each classes can be calculated by dividing the sum by the total number of values. So that will be like mean is equal to sum divided by n into n will be the number of classes, and into k, which will be the number of values. Okay, so that will be the total number of values. So that is a few insights about how LDA will learn. Okay, the model will learn. And coming to the LDA, how it prepares. So basically LDA is mainly classification of problem where you have categorical output variable. So it allows both binary classification and multi-classification. Okay, so basically LDA model uses sometimes a base theory to estimate probability. So naive Bayes we have already seen, right? So Bayes theorem, I hope everyone recalls the probability of k by like if considering a by b, b by a divided by the probability of a, those Bayes theorem. Okay, So just go back and refresh if you are not familiar. So they make the prediction based upon the probability that the new input data set belongs to each class. So this class which has the highest number of probability is considered to consider the output class, and then the LDA makes the prediction. Okay, so the prediction is made simple by using the Bayes theorem, which estimates the probability of the output class given to the data. Okay, given the input data, based on the input data, not the output data. Uh, they also make use of probability of each class and probability of the data belonging to each class. Okay, so the next point is the standard LDA model makes the Gaussian distribution of the input variables. So again, you can check the univariate distribution of each attribute and then transform them into more Gaussian looking distribution. Okay, so that is what it will be doing. Like here, the outliers can skew the primitive statistics used to separate the classes in LDA. So preferably, so it is preferably to remove them. So we'll be just ignoring them. So once all the outliers is kind of getting eliminated, so obviously it will get more into Gaussian looking. Okay, so the standard deviation also will be very less. And since LDA assumes that each point where each input variable has the same variance, so it always better to standardize your data before using LDA. Okay, so standardization step is also involved over here. So similarly, how we did with respect to PCA also, over there we just called it as normalization. Normalization on standardization means one in the same. So again, we can have the mean to be 0 and the standard deviation close to 1. Okay, so those are the things how we can prepare with our LDA data. So that is about linear discriminant analysis. So that is the reason like a linear discriminant analysis we choose over this one. So again, coming to like there is again extensions of linear discriminant analysis, and there's a drawback also. So I think maybe I'll just mention the drawback first. So basically LDA fails when it comes to mean of distributed distributions is shared. Okay, so we assume that the mean is actually almost similar to all the classes, so that's why it fails over there. And also the extension of LDA has gone through something like quadratic discriminant analysis QDA and flexible discriminant analysis FTA, and real life applications. So again, I had mentioned one or two, so now more is like facial recognition. So that is the most popular application of computer vision, where each face is represented as combination of numbers of pixels value. Okay, so in this case LDA is used to minimize the number of features to manageable number before going through the classification process. So it generates a new template in which each dimension consists of a linear combination of pixel values. If a linear combination is generated using linear discriminant analysis, then it is called as Fisher's face. Also again, you can call it as Fisher's linear discriminant analysis too. So that's why the face is also called as Fisher's face. Okay, so it is been used in medical fields also. So LDA is a great application for classifying patient diseases based on various parameters of the patient's health and the medical treatment which is going on. So on such parameter, it classifies diseases like whether it is mild, or moderate, or severe, and also with respect to stages, stage 1, stage 2, stage 3, something like that. So this classification helps doctors in either increasing or decreasing the pace of the treatment. And LDA, again, another very common application is customer identification. So it helps. It means with the help of LDA, we can easily identify and select the features that can be specific to the group of the customer who are likely to purchase a specific product in the shopping mall. So this can be helpful to identify the group of customer who are like mostly gonna purchase a product. Okay, so again, you can have like smaller predictions. So LDA used for prediction or making basically the prediction or decision making. Okay, so for example, whether you are likely to buy a product or not. Okay, so if you are having such kind of prediction, you can go ahead and give AdSense for them. Okay, so if a person is likely to buy it, so you will likely to give advertisement about the product to that person, so that he or she will end up buying it. Okay, and nowadays even robots are being trained using LDA. Okay, so similar like they can actually talk to simulated human. Okay, so talking to a simulated human work, so it can also be considered as classification problem. So in this case, LDA builds up similar groups of basic of parameters, like including pitches, frequency, sounds, tunes, and all. So for training robots also LDAs are used. And since we are talking about with respect to discriminant analysis, sorry, dimensionality reduction. So I think let me give insights with respect to LDA, difference between LDA and PCA. So PCA is unsupervised learning that does not care about classes, labels, and only aims to find the principal component to maximize the variance in the given data set. At the same time, LDA is actually supervised learning. Okay, so that aims to find the linear discriminant to represent the axis that maximizes the separation between the different terms or different classes of data. Okay, so whenever I'm telling about classes, it's nothing but they again features itself. And LDA is much more suitable for multi-class classification task compared to PCA. Our PCA is assumed to be a good performer for a very comparatively small sample size, and both LDA and PCA are dimensional reduction. So where usually PCA is preferred over LDA. Okay, again depends on the classification type of problem. So those are the insights about LDA. So that's all for this video.